The next section that we're taking a look at is called standard deviation. And you've probably seen one of these before. This is called a bell curve. Now, we often associate this with academic type things. So if you see this in one of your teacher's classes, you may just want to go ahead and run because you know that that class is either going to be really, really difficult or you're going to have to work the hardest you've ever worked before because you're competing with other people in your class for grades. Now, this is a standard bell curve. The reason why I say that you are going to be competing for grades is because your teacher or professor is already going to have a certain number of A's that they're going to give out, a certain number of B's, C's, D's, and possibly even F's that is already predetermined. And it doesn't matter what score you get, if you're at the bottom end, you're going to end up with a grade you don't really like all that much. This in the educational world is what we call norm reference testing, when you are going up against your peers or your classmates, as opposed to what you're probably used to, which is criterion reference testing, which is when you're up against the material, not up against other people. But we're going to take a look at how we use standard deviation. One of the most famous examples of standard deviation is the IQ test. And the way that we would use this is we would say that this line right here, 0 deviations, that is going to be your most average person on the planet. The average IQ is said to be 100. And so you can go one standard deviation to the right or one standard deviation to the left, and that would put you somewhere in about 68.2% of the population. So you will be within one, if you're here, you're within one standard deviation of the mean or of the median. Each deviation is, and you can see for the IQ, each deviation is 15. So if you're way over here at 145, then that means that you're pretty much smarter than, about 99% of the population. If you are at 2 standard deviations, then that means that you would be smarter than, or have a higher IQ, maybe not smarter than, but have a higher IQ than 97.9% of the population. Here, at 1 standard deviation, you would be smarter than, let's see, 13.6, 2.1, it's 15.7, 15.8. So you would have a higher IQ than 84.2% of the population if you were at 1 standard deviation from the norm. Okay? Now, what we do is we use the Greek letter sigma, and this is the lowercase letter sigma, to denote that we're using standard deviation. So let's go back up to our formulas here real quick. We've got the mean, and the mean is going to be an x with a bar above it, and that's equal to the sum of the numbers divided by the number, or the total number of values that we have. And you've been using this probably since you were in elementary school. You probably just haven't seen it written like this before. Then we have something called the variance. The variance is sigma squared equals capital sigma, so going back to sum, times x minus the mean squared over n. And then our standard deviation, we're just going to take the variance and we're going to take the square root of it. For problem number 1 in this section, we're going to look to find what is the mean, variance, and standard deviation of the numbers 6.9, 8.7, 7.6, 4.8, and 9.0. So what I've done is I've gone ahead and arranged columns and rows, and you can see that I prefer to have all these numbers in ascending order. So 4.8 down to 9.0. Now the first thing that we're going to do once we've established what our x values are is we're going to go and we're going to find the mean of all those x values. So you can see that we've got the mean is going to be 4.8 plus 6.9 plus 7.6 plus 8.7 plus 9 divided by 5. And then that's going to give us a result of 7.4. So I've gone ahead and put that result in each of these, in that column here, and it's going to be the same for every one because all 5 of those numbers added together, then divided by the number, is going to be 7.4. Now the next thing that we're going to do is we're going to figure out what is the difference between x and the mean of x. And so we're looking at, for 4.8, we've got negative 2.6. then we've got 0.5, we've got, or I'm sorry, this is going to be a negative 0.5, then we've got a 0.2, and then we've got a 1.3, and then we have a 1.6. Now, once you've established what the difference is, now we're going to take the solution to that difference and we're going to square it. So negative 2.6 squared is going to be 6.76. Then for negative 0.5, we end up with 0.25. Then we end up with 0.04. And then 1.69. And then once we've done that, we'll end up with 2.56. The next thing that we're going to do is take all of these values and add them together to get the sum, and that's going to give us 11.3. We now have enough information to come over here and figure out what is our variance going to be. So this right here, the sum of all this, that's this top line right here, that's the numerator. So once we get this value, we're just going to replace the numerator with 11.3, and then our total number of values again was 5. So we get 11.3 over 5. Now to find the standard deviation, we're going to take the square root of the solution to this, which is going to be 2.26. And we're going to take the square root of that solution, and that's going to give us our standard deviation, which is going to be approximately 1.5. And so that's how you're going to find the mean, variance, and standard deviation for a group of numbers. And you can apply this again to tests. You can apply this to basically anything that you're looking at, whether it's IQ scores, test scores, and you can figure out what the standard deviation is going to be.